right, so again, page 23 is where we begin today. Welcome back. Happy Wednesday. A quick look at the calendar shows us that we are continuing our discussion of voting. Today we talk about logic and the fairness criteria. Let me say right off the bat, the material today is vastly more difficult than the material from the first 2 days. So I'm just trying to be upfront with you guys. This is going to be a challenging day. You can get through it, but you should expect to be a little bit uncomfortable for parts of this. We're going to be pushing you today, all right? Also, voting project is assigned. So on your table, you should have a copy of the voting project. Looks like this. Take a copy with you. And let's just talk for about a minute about the voting project. It says here in the description that the very first thing you're going to do is devise a vote and conduct the vote. Many of you have done this already. That's what we filled out the other day, right? Last class, we voted on all these different things. So many of you have already done that. And in fact, I have your ballots here, which I will hand back to you today, okay? But if you weren't one of the people who got the ballot in to me on time, then you need to conduct a vote with 20 random people or 20 of your friends on Facebook, anything like that. But you got to get some data based on some question. That's the first step. Step number, or part B, is conducting the vote. Part C, it says create a preference schedule summarizing the vote. And I think that that happens right here on the next page. All right, so I've got blanks for you. In fact, I've got 2 blanks for you in case you make a mistake. But you're going to fill in all of this data by taking the raw ballots that you have and collecting them together, right? Anybody that voted the same gets put into a pile and then shoved into one column. This will be something you've never done before, so expect it's going to take a little bit of time to figure out exactly how to get it. And then you continue on to the heart of the project, which is part D, where it says figure out the complete ranking of each of the 4 voting methods. Now, on this handout, it tells you exactly which one is going on which page. So this very question 1 says you're going to do the plurality method. And so you got a bunch of space where you do the calculations. Down here, you're going to fill in some blanks and eventually tell me what the complete ranking is for the plurality method. Then on the next page, you're doing the same thing for Borda. The blanks change just a little bit, so read them carefully. Next page is plurality with elimination. And then finally, method of pairwise comparisons. Those are the 4 voting methods we've talked about. We're not talking about any more. So those 4, all right? I do. So the voting project is due right here, September 24th, exactly 2 weeks from today. Notice that I give you 2 weeks and not 2 days because I expect it's going to take a bit of time. So this isn't one you're going to want to wait until September 23rd to start thinking about it, all right? So honestly, you have the ability to do almost all of the project at this moment already. The 4 voting methods is the heart of the project. The part that you don't have, but that we're going to start talking about today, is on the last page of the project, where it says, is there a majority candidate? Is there a Condorcet candidate? If you did the reading, then those phrases will look familiar, but if you didn't do the reading, then you have never seen these phrases, and we're going to talk about those phrases today, okay? Do any of the methods violate the majority criterion? Do they violate the Condorcet criterion? Right? Questions that will look unfamiliar, but we're going to talk about them today. And then finally, writing a paragraph summarizing what you find interesting, and then 9 just asks you to be clear about exactly what you're turning in, all right? So I think that the directions are very clearly written in here. You just have to do some reading and give yourself enough time to make some mistakes, but still be able to turn this in within 2 weeks. Questions on the project? Okay, so let's see, that's good there. So let's jump back to page 23. And we'll start up here with number 1. So our reader for number 1, can we go to Ashley for 1? Thank you. Ryan, can you read number 2? Okay, that is my one rule. If the weather's all right, I'm going to go for a run in the morning. That's the rule, okay? 3, Samantha.
Either the weather's okay or either I run or I don't. Just so that each of the 4 possibilities below decide whether or not the broker or roll
Okay, so again, the only promise that I am making to myself, if the weather's okay, I'm going to go for a run. There are 4 statements here, depending on whether the weather is good or bad and whether I run or not. And we're going to look through here and we're going to decide in which, if any of these things, did I break my promise to myself. I promised myself if the weather's okay, I'm going to go for a run. So the first sentence, the weather is okay, I go for a run. Did I break my promise? No. In fact, I followed to a T what my promise was, right? And so this one right here, super. Did exactly what I said I was going to do. Part B, the weather's okay, I don't go for a run. Did I break my promise? Yes, that's the one where I lied to myself. I said, hey, if the weather's okay, I'm going to run. And the weather cooperated, and I didn't follow through with my promise. So this one right here is false. I lied. Part C. C and D are the tricky ones. I think A and B, people are pretty good. Yeah, A, you said what you did what you said you were going to do, and B, you didn't do what you said you were going to do. But C and D are kind of tricky. The weather is not okay. You know what? I'm going to go for a run anyway. I don't mind running in the rain. Did I lie to myself? See, we've got some yeses and we've got some nos. A few more nos than yeses. The weather is not okay. Let's think about the promise that I made. If the weather is okay, I'm going to do something, right? I have no contingency in that plan for what I'm going to do if the weather is bad. All I'm doing is making a promise if the weather is good, which pretty much means if the weather is bad, I can do whatever I want. I'm not bound to anything because I haven't made any guarantees in that case. So if the weather is not okay and I go for a run, super. I didn't lie to myself. I didn't say I wouldn't run if the weather was bad. So this one's all right. It's a true statement. It's not a lie. Part D, the weather's not okay, and I decide I'm not going to go out for a run. Did I lie? No. Again, I only made a promise if the weather's okay. The weather's not okay. I didn't guarantee that I would have to run, so it's okay if I don't run. So there's only one way for an if-then statement to be false, to be a lie. That's if the if part is true. Remember, the if part was the weather being okay. So that part was true. But then the then part, I go for a run, was false, because I said I didn't go for a run here. So I think that's exactly what it says here in 4. The only way an if-then statement is false is if the if part is true and the then part is false. Okay? So that is a very brief detour into the field of logic, but we need to be able to understand if-then statements in order to tie them into this voting stuff. So let's talk about 5. And we're going to go back to Leah for 5. Does that seem fair? If one candidate has a majority, does majority mean more than anyone or more than half? More than half. If one candidate has more than half of the first place votes, they should win. Seems reasonable, right? They are the preferred candidate for more than half of the people who vote. They should win. Okay, let's take a look at number 6. 6 has the following preference schedule. We've got 4 candidates, A, B, C, and D. How many people voted in that election? 7 people. Okay, so we just read across the top. 7 voters. And if there are 7 voters, then how many votes are needed for a majority? 4, right? Half is 3.5, but you need more than half. So 4 is a majority. Did any candidate have at least 4 votes? Yes. Candidate A, right? More than half the people said A is the best. So in some sense, it would be fair if A won this election. So we can say A is the majority candidate. So lots of vocabulary that's going to be kind of new. Be patient with yourself as you get used to this new vocabulary. But we say that A is the majority candidate because A had a majority of the first place votes. In most elections, there is no majority candidate. So you don't always have to have somebody with a majority. Okay, so far so good. Part B says who's the winner using the Borda method. What I'd like you guys to do with your neighbors is just calculate the Borda score for A. You can copy the ones for B, C, and D. I didn't want us to spend all that much time on it. So we're just doing A. Zeke? Yeah. So it turns out last place counting for 1 point or 0 points makes no difference in the grand scheme of things. The complete ranking will be the same order as before. The scores will be different. Yeah, the scores will just be off by a little bit. Our choice is to make last place 1 point every time. Yeah, okay. So with your neighbors, see if you can tally up the score for A, and let's see if we can agree on this. So we've tallied up, we've got A is 19, and you'll have to take my word for it, but you can check the other scores later, but maybe copy them down right now. The point is, who's the winner according to the Borda method? C. C has the most Borda points. So C is the winner using Borda. Okay. And at the moment C is declared the winner, one of these other candidates is going to start screaming from the top of their lungs, "That's not fair." Which candidate has a gripe with the outcome of this election? Is A. Why? Not because A, has sour grapes. It's because A had what? Had a majority of first place votes. And I want to tweak one thing Tony just said. Tony said the most first place votes. Is that the same as the majority? No, right? We got to say majority. Because otherwise, every time somebody's going to have the most first place votes, right? It's the only time they're going to start screaming is if they had a majority of first place votes. Wait a minute, not only did I have more than anybody else, I had more than half. I crushed everybody, and I didn't win. Are you kidding? So in a very real sense, A has a reason to gripe about the outcome of this election. So we'll summarize here in 7. I think we're back to Eric. Let's pause right there. Do you guys remember the only way the if then is false is if the if part is true, like the weather's okay, but the then part is false. I don't go for a run. So the if part, if somebody has a majority, then they should win. The if part was true. A had a majority. Then they should win. It was false. They didn't win. C was the winner. Keep going, Eric. Mm-hmm. Okay, that's it. The Borda method violates the majority criterion. Okay, let's continue on to Brendan for 8. Okay, so in your groups, read A, B, C, and D. One of them should feel unfair. The other ones should be just fine. Circle the unfair one. Okay, which is the one that feels unfair? B. This is the only thing that we are looking for. If you look for a violation of this majority criterion, remember I promised lots of new vocabulary today. The only way we're going to have that violation is if you happen to have a candidate that gets a majority of first place votes and they don't win the election. The bottom 2 cases, no candidate had a majority. This criterion is not even in play. Okay? Nobody has anything to complain about if they didn't have a majority of first place votes in the first place. Okay, let's look at number 9. I think this word is pronounced Condorcet. Matt, can you read number 9? Okay, let's think about this carefully. If one candidate is preferred against everybody else head to head, you guys remember we did the method of pairwise comparisons? And so we'd compare every candidate versus every other one. If one candidate happens to beat every other candidate in a head-to-head, they should win. Seems fair, right? This one person is preferred against everybody else, they should win. Okay, let's take a look at number 10. I think there's some doubters in the back. Jen, can you read 10? Okay, so here's the outcome of our election. The members of the band themselves are going to decide which of these invitations to accept. So they're going to go to one of these 5 bowl games. And so part A says, which bowl games should the band perform according to plurality? So plurality means we're only looking at what kind of votes? The top ones, the first place votes. So who has more first place votes than anybody else? R, the Rose Bowl. So we'll say R has 49, H has 48, and then F has only 3, right? So definitely the Rose Bowl wins the plurality method, yes? Did the Rose Bowl have a majority of first place votes? No, right? They didn't have more than half. They had more than anybody. Unless there's a tie, you'll always have somebody with more than anybody. But the only time that other thing we just talked about comes in is if somebody has more than half. Okay, part B says, is there a candidate who beats every other candidate in a head-to-head? How many candidates are in this election? 5. There was a formula that we wrote on the board last class, n times n minus 1 over 2. It comes out to 10. There's 10 head-to-heads. A versus B, A versus C, A versus D, A versus E, B versus C, etc. There's 10 of them. We don't need to do all 10. There's not that many candidates here that have a chance of beating everybody head-to-head. Who were the 2 like way up there at the top? H and R, right? They had the overwhelming majority. They had 97 of the 100 first place votes. So really the only ones that have any hope of beating everybody are H and R. So how about we just look at those 2? So we're going to do H versus R first. So looking at the first column out of H and R, who do they prefer? They prefer R, so we're going to give R 49 points right there. The second column, H or R, who do they prefer? They prefer H. So H has 48, but I'm not going to write it just yet. The last column, they really like F, but that's not what we're after. We're just looking at H or R. Who do they prefer? Is H, because H is higher than R. So how many votes does H get? 51. Okay, fair enough. So narrowly, H is preferred to R. And that means that if there's going to be somebody that beats everybody head-to-head, who does it have to be, H or R? There's got to be H, because R just lost a head-to-head. So the only other things we need to look at are the H comparisons. So for example, H versus S, and H versus O, and H versus, what do we have? F. Yeah, and I think we can see that H is going to destroy everybody, because as long as you get rid of that purple in the first column, the R, like H is second place for those people, right? Like H is going to destroy everybody else. I mean, you can keep score if you want, but I mean, I think it's going to be 100-0 for most of them, everything except this guy, right? So this is like 97-3, and then a donut on these 2. Okay, not so bad. So here's the question. Is there a candidate who beat everybody head-to-head? Yes, H beat everybody head-to-head. Do you think there's always a candidate who beats everyone head-to-head? No, this is a sometimes it happens, usually it doesn't thing. Okay, so this is an unusual one where we do have somebody who beats everybody head-to-head. So that's our answer to part B. Is there a candidate who beats every other candidate head-to-head? Yes, candidate H beats everybody head-to-head. So we conducted a plurality election, and who won? R won. But H beat everybody head-to-head. So who's going to cry foul based on the outcome of that plurality election? Who won the plurality election? R. R is thrilled. Who's the one that's going to complain they got gypped? Is H. Because why? H beat everybody head-to-head, and somehow they didn't win? That's not right. This is exactly what this thing that Matt read to us says. Again, it's the Condorcet criterion. If candidate X, I'm going to change this X for a second to the letter H so we can be specific to this election. If candidate H is preferred by the voters over each of the other candidates in a head-to-head, was H preferred over everybody? Yes. Then that candidate, H, should be the winner. But was H the winner when we did this plurality election? No, that's not fair.
So is it only if everybody else not?
Right, it's only if they beat everybody else does this criterion come into play. So let's fill in the blanks here. It says in this election, the blank method, that's one of our 4 vote counting methods, violates or doesn't violate the blank criterion. What was the vote counting method that we used here? It was plurality. Now it's really easy to say a different answer. Plurality is the right answer, but we just did some head-to-head comparisons. And so it's really easy to think that we were doing the method of pairwise comparisons. But that's not how we found a winner. We found a winner by plurality. It happens that this Condorcet criterion says you got to talk about somebody beating everybody else head-to-head. But in this election, the plurality method, we'll leave that violates, doesn't violate unknown for a second. But what was the criterion that was relevant? This Condorcet criterion. It's a French person's name, which is why I think it's Condorcet and not Condorcet. Okay, and was there a violation in this election? Yes, H really feels gypped. They beat everybody head to head, and somehow, by hook or by crook, they didn't win. And so the plurality method violates the Condorcet criterion. Okay, 11 is quite like a problem that we just answered up above, so we don't need to read the whole directions, but there are 4 sentences there. One of them should feel unfair. The other 3 should be okay. Circle the one that's unfair and discuss with your neighbors. But are we feeling good that part B is the one that feels unfair? There was a candidate that beat every other candidate, but somehow they didn't win. Not fair. In part A, if you have a candidate that beats everybody else and they win, super. Like things work the way they should. Who do we think maybe should have won this election? H. It feels like maybe H should have won. So if we count the votes somehow and H wins, great. There's no violation there. It's only if you have the if part being true and the then part being false that we've got the problem. Somebody beat everybody head to head, but they did not win. Okay, moving on to number 12. Now let's just give you guys like a quick summary of what's happening here. The first 2 classes, we talked about 4 vote counting methods. Plurality, Borda, plurality with elimination, pairwise comparisons. Each of those 4 methods finds a winner of an election. That's what we accomplished in the first 2 classes. Today, we're going to talk about 4 fairness criteria. We have seen the first 2. The the majority criterion and the Condorcet criterion. And there are 2 more, and we're going to see them in just a minute. In my mind, these are 2 parallel tracks, like 2 train tracks running right next to each other. The one train track that we talked about the first couple of classes was how do you find the winner of an election? And we discussed 4 different ways to do that. Once you've found the winner, we'll then jump over to the other track and we ask ourselves, was that fair? Was there a person who should have won that election, and if so, did they? So it's 2 separate tracks. What we are talking about today is not about finding the winner of an election. It's about looking back after an election has taken place and deciding whether or not it was fair. Okay? So 2 parallel tracks. There's a lot of overlap in terms of the words on these tracks, so it's easy to get them confused. But today is just about looking at an election that already completed using one of the methods we discussed in the first 2 classes and asking ourselves if it was fair. Moving on to number 12, monotonicity. Jeff. Yes. Okay, so there's a lot of stuff going on in that criterion. We're going to look at a concrete example which will make clear what Jeff just read. Zeke, 13. Okay, so here's a table. This is an unofficial poll, right? The election is going to happen a couple of days later, but we just want to see where people are at this moment. And in part A, it says we're going to use plurality with elimination. So let's do this right now. This will be a good review of one of our methods from last time. A, B, and C, I don't know if you can squeeze them all in there, not a lot of space. Maybe we'll go this way. So A and B and C, and I see the word plurality in there, which means initially I'm only looking at what kind of votes? First place votes. So looking at first place votes, I see A in 2 places. How many first place votes does A get? 11, 7 and 4. So A has 11. B only appears once with how many votes? 8. And C appears just the once with 10. And so altogether, we should find out how many voters we have. 29? 29 total, which means a majority is 15, more than 14.5. Okay, so did somebody have a majority? Because if somebody has a majority, they win and we stop. That was the first thing for this plurality with elimination. Does somebody have a majority? No, which means we need to eliminate. Which candidate is the natural choice to eliminate? Is B. So we eliminate B. And so then we're going to put our new totals over here, A and C. And so eliminating B, you can cross them all out, but the only B's that matter are the ones that were in the first row. And so these 8 votes right here that used to go to B, who gets them now? C gets them now. So A hasn't gained anything. A is still going to be stuck at the 11, but all 8 of those votes just went to C. They had 10 plus the 8 more, 18. Okay, and did somebody have a majority now? Yes, C has 15 or more, so C is the winner of plurality with elimination. So that's our answer. C wins. C wins. Okay, that's just a review of plurality with elimination from last time. Now we're going to go to part B, and we'll come up here to Sarah. Okay, so the people in the 4th column are just going to change their vote a little bit. They see that candidate C, Calgary, is going to win, and they're just going to decide to vote for the winner. So after the fact, they can go home and tell their friends, hey, I voted for Calgary, and they won. So that means that we're just going to put C up here, which means that this column now becomes what? If we just push C up, it becomes C, A, and B, right? Now, if there's already a C, A, B column in there, then we shouldn't duplicate it. We're just going to merge the columns together. So I'm going to copy the first column, which was A, B, C, and still how many people voted that way? 7. And then we're copying the second column, which still has 8 people, B, C, A. But now the third column, which is C, A, B, has some new folks that decided to vote that way. Used to be 10 of them there. They're still there. But then these 4 people decided to change to CAB. So how many people are really CAB? 14. Everybody comfortable? This is the first time we've merged 2 columns together, but I think it's a natural thing to do. Okay, so there's our new election, or our new preference schedule. All right, so before we actually find the winner, because we have to do plurality with elimination just from scratch, who should be the winner? Who was the winner when we did plurality with elimination before? It was C. And then what happened? Some people put C even higher, right? Everybody stayed the same except for this 4th column who ranked C even higher. So if C won before, then they should like super win now, right? I mean, like they should win harder than they won. I don't know how to say it. I mean, like they should really win, right? Like they're stronger than they were before and they won, so they should still win. Let's see what happens. A equals, B equals. C equals. Okay, first place votes. Yes, Jackie? Yeah, no problem. Okay, so this is part of what Sarah read to us. It says that the people in the fourth column, after they find out that Calgary is going to win this election based on the unofficial results, they decide to just move Calgary up. And so the people in this fourth column that used to be ACB, they decided to put C up to the top and then put A in the middle and keep B in the bottom. So this column here used to be ACB, is now a CAB. See it? But there's already a CAB column there, and so the fourth column now agrees with the third column, so we're just going to mush them together into the one CAB column with a total of 10 plus 4 or 14 people. Okay. All right, so let's look at, again, plurality with elimination. So we start with first place votes. What's the total for A, B, and C? 7, 8, and 14. Okay. No problem. And does somebody have a majority? No, so we do have to eliminate. Who gets eliminated here? A with the fewest number. So we eliminate A. So I'm going to cross off all the A's, although we know the only A's that matter are the ones that were in the first place row. So the only column that matters is which one? It's the first one. And those 7 votes now go to B, right? Because A is no longer there to get them. Okay, so A is out of the picture. B is here, C is here. C didn't gain anything, so C is still stuck at 14. But B just got how many more? 7 more. So 7 plus the 8 is 15. So who wins? So B wins. What's surprising about that? That it wasn't C, right? C won the election. Then everybody voted the same exact way, except some people said, hey, I like C even more than I did before. So C should have gotten stronger, but somehow they lost. And that doesn't feel fair. So, get our summary down here. Megan, could you read part C, please? Okay, so we're filling in the blanks. We had a certain vote counting method. There are 4 choices. Plurality with elimination was the choice that we were looking at here. So plurality with elimination. Then we got to find the name of the relevant criterion. We've seen 3 of them so far. What was the name of the one that's on this page? Monotonicity. And in this election, was there a violation or not? There was, because which candidate? C should have won. By all rights, C won this election, and then they all of a sudden didn't. So plurality with elimination violates the monotonicity criterion. Okay. I promised you today we had 4 new criteria. We have seen 3 of them. Yes, Zeke. Yes, you should be upset. Yeah, so what went wrong here? I mean, like, by all rights, C should have won this election. They won, and then they're stronger, and then they didn't win. Sue Ann.
Because they didn't have a majority and they got their next choice.
That's the problem, is that the people, so when C won this election initially, who got eliminated first? It was B. And when B got eliminated, who did that really help? That really helped C, right? Because these were the people whose votes all of a sudden got shifted around. The people that really like B first, well, their candidate got knocked out, and they like C second best, and that's what gave C the victory. But then when we shifted here, A didn't have enough first place votes to stay in to make it to the second round, and A ended up eliminated, which means the column of people that was in play completely changed. This was the column whose votes changed. And when these guys right here lost A, who benefited? It's B, right? Over here, C was the benefitor. But over here, it was B. And we should be upset by this. Like this, it's just not fair. And that's kind of the point. That's the point of this criterion is like, there is something flawed about plurality with elimination because this can happen. And that's not fair. Okay. That's not to say that every single of our 4 vote counting methods that we've talked about violates the monotonicity criterion. Like that's not what it says. This is just saying in this case, plurality with elimination, drop the ball. Right? But maybe if we had done Borda, C would have won the first time and C would have won even more the second time and we would say, oh, this is great. Monica.
So is like the plurality elimination method always going to violate?
That's a good question. Is the plurality with elimination always going to violate this monotonicity criterion? The answer is no. It violated it in this specific example, and those numbers were chosen to get this kind of reaction where we see something unfair happen. It's not to say that plurality with elimination always messes things up, but it can. It can mess things up. And maybe we should seek a method that won't mess it up, like ever. Right? Maybe there's some other vote counting method that will never give us this unfairness. That's what next class is about. It's talking about like which is the best of these 4 vote counting methods. Okay, today I said 4. We have the 4th one right here for Christopher. Could you read 14, please? Okay, let's take a look at 15. We'll go to Ricky. Can you read 15? Okay, so this is the mayoral election here in Greenfield. How many people voted? 7. It was a slow day at the polls. Okay, so part A. Who wins using plurality? Let's get the work up here. A equals, B equals. So notice that every time we do plurality, even if you can just see what the winner is, I'm always writing the 3 scores because that's what I'll expect you to do on my test coming up is tell me the 3 scores and then tell me who wins. It's not a lot of work, but it's just a little bit of work to show me you know what you're counting. Okay, how many votes for A? 3 for B, 2, and for C, 2. So who's the winner? A wins. Super. No controversy yet. Let's go to Sue Ann for B. Okay, so we've already voted. We can't ask people to go out and vote again. But B, because of this scandal, has decided to withdraw on their own accord. So just cross the B's off. And we're still doing plurality. Who gets the first 3 votes? A gets those 3. Who gets the next 2? C. And then here's where things go funny. Who gets these 2? Is also C. Right? They voted for B first, but B is now no longer a viable candidate. So we got to assume that those people think that C should be the winner after B is not available. So what's the score? How many votes for A? 3, and for C? 4. Okay, let's write that down. So we said that A has 3 and C has 4. So who wins? C wins. Okay. Who won initially? A wins the election initially. Then one of the candidates who didn't win drops out. Now who wins the election? C. Who's crying foul? A. A won the election by all rights. right? The votes were cast. All we had to do was count and declare A the new mayor of Greenfield. Then somebody who is meaningless in the election, candidate B, decides to withdraw, right? A should still win, but all of a sudden a different candidate wins, and A is not happy, right? And so that right there is this independence of irrelevant alternatives criterion. I'll say it again. If a candidate is the winner, just flat out, I don't care how we count the votes, but they won, but then there's a recount, and one of the non-winning candidates drops out, then candidate X, which was the winner before, should still be the winner after. Right? It shouldn't matter that one of the losers dropped out of the race, but it did in this case. It changed the outcome. So let's fill in some blanks. In this election, what was the name of the vote counting method? Plurality. We're going to skip the violates, does not violate. What was the criterion? Independence of irrelevant alternatives. You're probably going to want to abbreviate that as IIA or dropout, either way. And did this particular election show a violation or not? It did. Again, there was this fundamentally unfair thing that happened. And so the plurality method here violates the IIA or dropout criterion. Okay. Let's look at 16. Where are we now? Monica. Okay, so if you're after a violation, there's a specific thing you are looking for in each case. For the majority criterion, this whole thing right here is all about finding a violation. So that is very specifically what we are looking for. You want to find a candidate who has a majority, but somehow they didn't win. That would be a violation, right? For the Condorcet criterion, you want to find somebody who beats everybody head-to-head, but they didn't win. That's the conclusion for all of these. In order for there to be a violation, you need to have like the obvious winner, but they didn't win. So it's always, but they didn't win. For the monotonicity criterion, you've got your vote, somebody wins, then people change their mind and vote him higher, but all of a sudden he doesn't win. That's what it says in there. And then finally, this IIA business, somebody wins, but then there's a losing candidate that drops out, and all of a sudden it's a different winner. That would be a violation there. Okay. As I promised, the material here is harder than it was the first 2 days. I've taught this course here at GCC. It's harder, right? It's just a lot more, there's a lot more involved in terms of thinking, and there's new vocabulary that you're not used to. So I've taught this course maybe half a dozen times here at GCC. And for maybe the first 3 times that I taught this course, I was fumbling around in this section. Like I would say the wrong words. I'd have to really think, okay, which is the violation and does it or does it not? And it like honestly took me like 3 times teaching this course to really get to the point where I felt super comfortable. Now, I don't want you to plan on taking this class 3 times, but I do want to say be patient with yourself. It takes time to understand this new way of thinking about elections. So we have 22 minutes. See how far you can get on this voting activity with your neighbors. Raise a flag if I can help.